Double, double, toil and trouble, fire burn and cauldron bubble. A Shakespearean drama or just another day in cybersecurity? With constant new threats, ever-evolving data source, and a flood of information to process, alert fatigue and information overload are real issues faced by teams dealing with all this toil and trouble. To alleviate that toil, LLMs, which is the subset of Gen AI that focus on processing and generating text or language, can be used effectively for many parts of cybersecurity, as shown here, from threat detection and analysis to security training and awareness, and everything in between. And pretty much anywhere natural language is used, from standards, documents, messages, reports, log files, etc. In addition, thanks to LLMs, English or natural language has become the hottest new programming language, allowing non-developers to better interact with machines. So maybe you have a specific problem and you're wondering if LLMs can help solve it. Well, to explain some of the capabilities and choices when it comes to LLMs, I'll talk through the specific problems I was trying to solve and how I went about it using LLMs. The specific problems are highlighted in a Cloud Security Alliance report released only last week that calls out some of the known issues with vulnerability data. A surge in CVE submissions, data quality issues, and calling out impact details as being especially important for end users. So this aligns with my focus on the upstream enrichment of CVEs so that the information will be better quality, more timely, and useful to all of us downstream users. In numbers, there's a 35% year-on-year increase in published CVEs, trending towards 40K CVEs published this year, with a current NVD backlog of about 20K CVEs to be processed. On prioritization difficulties, I addressed that problem previously and shared my approach in the risk-based prioritization guide I led with the thought leaders in this space and the folks behind the EPSS, Exploit Prediction Scoring System, SSVC from CISA, and in general, the folks and thought leaders in this space. It's a highly opinionated, pragmatic, user-centric view with the data analysis behind it. So check that out if you're having difficulty prioritizing the deluge of CVEs. Fun fact, for broader context, I do refer to the Effective Vulnerability Management book by Dr. Nikki Robinson, who will be presenting later on. So honored to share the stage. An important component of CVE info is the weakness information, or the CWE. But CWEs overall have a usability problem per the MITRE CWE folks. The spec itself contains about 1,000 weaknesses, over 3,000 pages, very difficult for people to grok. And this leads to issues. Either the CWE is not populated or it's inaccurate. So what people want is a down select capability to go from like 1,000 weaknesses to a few that they can select for the given vulnerability. Our industry relies on this CVE and CWE info being timely and accurate, but today it is populated manually, and as I said, there's a backlog of CVEs. So this is where LLMs can help assist. Specifically, the problems I set out to address with LLMs were creating a good vulnerability description from existing vulnerability links and advisories, because some of the CVE descriptions, as we know, are not useful or informative, or from a vulnerability description, extract out the key phrases. So maybe I want to know what's the impact or the root cause for one or many vulnerabilities. Or maybe I want to accurately assign a weakness CWE because they're either not present or not accurate. Or maybe I want to further categorize the impact into one of 8 MITRE technical impacts, so I can understand the real impact to me as a user. So these are a selection of CVE enrichment use cases done manually today, where LLMs can help alleviate the toil in dealing with the deluge of CVEs. And really, it's all about reducing the manual toil to improve the quality and the speed at which CVEs are processed. And that's the area that I focused on for LLMs. But in general, they can be used, as we saw, in lots of areas in cybersecurity. So introducing the cast in this adventure, there's me as the protagonist, but it also features the Cybersecurity Infrastructure Security Agency, CISA, and their Vol Enrichment Program, where they enrich CVEs, and also the MITRE Common Weakness Enumeration Root Cause Mapping Working Group. I refer to them as the CWE gods. They also have a starring role in this adventure. I've liaised with both, and this work has contributed to both. Lo, what fortune by chance's fair design, where mortal toil once dimmed the light, now artificial minds with wisdom shine, and mitre's patterns spring forth clear and bright. I'm no Shakespeare, so I'll start my story with the tried and tested once upon a time. I was reading a LinkedIn post. It was about CVSS4 and CISA enriching CVEs. The post included an arbitrary example of a CVE that was enriched by CISA. And what I noticed was that the weakness, the CWE, looked wrong for the given vulnerability description. Now, to notice that requires an understanding of software, type confusion, security certificates, and CWEs. And not many people would have that combined understanding. So then the question came to mind, can LLMs help with CWE assignment? So I asked 3 independent state-of-the-art LLMs. The intuition here is that if there's consensus, in other words, if the 3 independent LLMs agree, they're probably right. So bare minimum prompt used, and there was consensus on the answer. CWE 295, improper certificate validation for that description. I manually review that, made sense, great. So then, not knowing what to expect, I reported the incorrectly assigned CWE via GitHub issue in the CISA Vulnenrichment repo. And Vulnenrichment were very responsive, and it was promptly resolved. Excellent. But then the question came to mind, I wonder how many others are wrong, and can I automate detection of these wrong CWE assignments? And so I did. I automatically asked the 3 state-of-the-art LLMs if they thought the CWEs assigned by CISA were correct or not. There were some errors due to models not supporting structured JSON output at the time, and some false no's because some of the vulnerability info was not in the description but was buried in the CVE reference links, or some of which those links no longer existed. But in general, I was able to quickly identify and validate wrong CWE assignments. There was approximately 1,800 at the time, CVEs enriched by CISA. And the breakdown is shown here color-coded, and the red ones are the no's. So reviewing the no's, I was able to file a report with CISA Vulnenrichment. And I also created some issues, just a subset, in the GitHub repo. So then the question came to mind, can we create a CWE expert to help assign? So I did. The traditional approach used in research papers to date is to train a classification model using just the CV descriptions and the assigned CWEs. But as Steve, the CWE tech lead, says, you can train on bad mappings to learn how to do good mappings. Makes sense. So the alternative approach I presented here is to use all the existing rich documentation as used for humans and known good examples, and fed it to an LLM so we can ask questions of it. So on the back of my involvement with CISA Vulnenrichment, it was suggested I talk to the CWE gods. So I reached out and I was invited to present to them. Now, Steve is a person who does not suffer fools. He asked how I could be sure the suggested assignment was correct. And I said, well, because the answers are based on your document and the examples you wrote. That's how the technology works. He said they'd seen many LLM proposals, but this was the most promising approach they'd seen far. So now I'm currently working with the CWE gods, helping them to get up and running with this technology at production scale. So you're probably asking, so what did I present? Oh, very simple. To minimize time to value, I used NotebookLM. It's a free and powerful tool from Google, and it's possible to build the equivalent in Google with Vertex AI. So good for rapid prototyping and evaluation. And per the extract shown here from my CyberSec AI guide, LLMs change the information retrieval paradigm. Instead of searching for information where we go to the information, we can chat with our documents and ask questions of them so that the information comes to us in the form of an answer. And NotebookLM allows us to load one or more documents and ask questions of them. So you can even create a lively podcast from your documents at the click of a button. I did that with the 80-page EPSS white paper and had an engaging podcast as a result. So I prepared the CVE specification as a set of JSON files needed for our CVE expert, taking out the parts that weren't necessary, like the history, and imported it into Notebook LM. And then we can ask questions of the expert. Let's see what that looks like. So here's an example. First question, what CVE IDs are associated with buffer overflow? Simple question. I get back a response and it lists the CVEs, but it also importantly lists the references. So each numbered bubble is a reference that I can click into to see what documentation from the JSON it was referring to. So this can significantly validate the response and reduce the hallucinations. Okay, so that's easy. That's asking it questions that are in the document. How about if we ask about topics that are not in the document, not in the CVE specification? We ask the model, hey, assign a CVE or CVE based on its detailed understanding of the specification, the CVE spec, and the known good examples. So here we can see a down select capability that users want. We've gone from almost 1,000 CVEs in specification to about 3 with a rationale and a recommendation and additional context. And there's a known good example that's quite similar to the existing CVE. A traditional classifier model would just spit out an answer like 42, but without the rationale, the examples, the context, and the inability to ask further questions. So now, with my expert, I can ask further questions. Are you sure? What about? Are you sure? Can you give me more examples for this? I can interact with the expert. And remember, we got from 0 to here in a few minutes for free. Okay? And anyone can reproduce this. So then the question came to mind, can we create a production CVE expert? And so I did. Through patterns wise of reflections art divine, where agents wield their tools with measured grace, each vulnerability they do assign, while CVE enrichments find their place. For the production CVE expert, we decompose the problem into separate tasks. We assign the task to agents, where an agent is an LLM dedicated to a specific task. Example, memory, tools, information, training, or tuning. So of note here is that the first draft of this diagram was created using Claude Sonnet. I asked it to create a mermaid diagram based on details I provided in the prompt, where mermaid is a text to diagram standard. And based on the diagram it created, I revised it, fine-tuned it manually, and then I asked Claude to create the Crew AI or line graph code from the diagram to create a multi-agent system. And for this production CVE expert, we're using 2 agentic AI design patterns. We're using reflection, which can improve performance significantly. So to understand reflection, imagine you were asked to write an essay, but you were not allowed to read what you wrote. With reflection, where we ask the LLM to review what it wrote, performance can be significantly increased, like 20% in some papers. And tools allow the LLM to lexically or semantically search for CVEs in this case, with related root cause or weakness and product. Now, this particular problem is a bounded problem, well-defined set of tasks, so the other patterns were not used. In my opinion, the technology for these patterns is less mature currently, but ultimately this is what will empower agents of the future. They will be more autonomous and better at planning and better able to collaborate. So how does our CVE expert respond now to a vulnerability description? Well, this is a real assignment report as filed with CISA in their enrichment repo and created automatically by our expert. It contains several sections per the assigned tasks. We have the extracted key phrases for the vulnerability description, including the root cause, weakness, etc. We have the known good examples of similar CVEs, whether they're from the observed examples or the top 25. And based on all this, the assigned CWE associated abstraction and mapping info is provided. And we can see the root causes in bold in each section, making it easier for humans to identify it throughout. And this is just one of several CWE assignment reports I submitted to CSAP. So overall, the building blocks I built so far, and I can see there's a lot of interest in CVE credits. Maybe I'll take that one on too in the chat. But the building blocks I built so far are CWE assignment and, you know, working with the CWE gods and bringing that to production. There's the vulnerability key phrase extraction that's used as part of that to extract out the root causes and the weaknesses to better determine the CWE assignment, the weakness assignment. There's MITRE technical impact assignment, where MITRE prescribe 8 specific impacts, things like read data, modify data, etc., that give a better classification of impact for all possible CVEs. And then there's CWE validation, as in validating at scale. So these can be used together in a multi-agent system or separately in batch mode. If you want to process tens of thousands of CVEs, maybe you run key phrase extraction first as an example, or the validation first. So they're just building blocks. You can use them as whichever way. These are just some building blocks, as I said, for the specific problem cases I was looking at. I will add more over time. I can see there's a massive demand for CP credits. Yeah, I'll consider that for the future. As minds artificial grow wise and free, their purpose aligned with mortal design. Their agency blooms like spring's first tree. Their powers expand beyond present time's confine. So current state is that we have advanced prompting, RAG, and the beginnings of agentic AI. There's lots of change in progress and lots of hype and some utility. In addition to better, faster, cheaper that we would expect of technology in general, the future for LLMs will be that they will have more agency, be more autonomous, adaptive, personalized, etc. But amidst all this technological change, keep in mind that don't fall in love with models. They're expendable. Fall in love with your data. And to that end, familiarize yourself with the concept of getting your data AI ready. Even if you're not Gen AI ready, get your data ready. Looking to the future and what Gartner says, they call out the agency gap and they provide some very specific predictions for the future. Humans are high agency, adaptive, capable of proactive planning and achieving complex goals, whereas chatbots are low agency, static, reactive, can do simple tasks, etc. Whereas LLM-based assistants are somewhere in between, with the gap closing between humans. And during this gap period, agents can tackle the toil, like the examples I've shown here, freeing up humans to tackle the high agency tasks, which in the future, agents will. So while there's an awful lot of hype around LLMs and Gen AI, there is also utility. So learn to use the Gen AI tools and get your data ready. You can see how me as an individual in my free time using LLMs can have a large impact in areas where LLMs are not being used to date. But that holds true in general for any area. So Gen AI can free up your mind from the day-to-day toil to focus on bigger things. Alternatively, it can allow you to compete with the people who already know how to use the Gen AI tools. I'm open sourcing all of this to enable others and will continue to work with the CWE gods, CVE enrichment, and others to improve CVE enrichment. And I'll continue to document my learnings in the free OpenAI for cybersecurity guide. All things are ready if our minds be so. Perish the man whose mind is backwards now. Thank you.